Standard 10th Mathematics Part 2 Chapter Trigonometry. In video number 4, dealing with values of trigonometric ratios of angles measuring 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees. Children, till now we were finding out the trigonometrical functions and their multiplicative inverses in a general form by considering any one acute angle without considering a particular angle as 30 degrees or 60 degrees or any other. So, particularly now, if we give some measurement for the acute angles, now we know acute angles lie from 0 degrees to 90 degrees, then what will be the value of any trigonometrical function of that particular angle, that is an acute angle? As you can see on the table over here, sine of 30 degrees, how is the value? Half. Cos of 60 degrees, again how is the value? Half. Take tan of 30 degrees, how did we get the value? 1 upon root 3. This we have already studied in the earlier classes, but let's recall. To begin with, let's consider a triangle, that is an isosceles right angle triangle. Now when I say it's an isosceles right angle triangle, what do I mean by it? I mean to say that one angle, one of its internal angles is 90 degrees, and when I say it is an isosceles right angle triangle, the other two angles definitely are congruent. So let's mark it with identical marks. That means each angle will be equal to how much? Each angle will be equal to 45 degrees. So that is an isosceles right angle triangle. Now how do we find out particularly the trigonometrical functions, and later on then it is easy to write down their multiplicative inverse ratios. So to begin with, how do we know that sine of 45 is 1 upon root 2? Cos of 45 degrees is also 1 upon root 2. Tan of 45 is equal to 1. How did we get these values? So let's recall, children. We do not know the measurements of any sides, but still we have got the answers penned on the board. To understand that, we know when it's an isosceles right angle triangle, the measurement of the sides AB and BC are congruent. So let's put them or assume that the ratio is 1:1. By using Pythagoras Theorem, what will be the value of AC, that is the hypotenuse? By applying Pythagoras Theorem, for triangle ABC, what do we get? We get AB square plus BC square is equal to hypotenuse square, that is AC square. How much is AB over here? It is 1 unit. So 1 square plus 1 square will be equal to AC square, which is unknown yet. 1 square is 1 plus 1, which is equal to AC square. 1 plus 1 gives us 2. That is AC square, taking the square root on both the sides. Finally, we get AC is equal to root of 2. So, the value of AC is root 2. Now, let's see. Let's take any one acute angle. Both are 45, so the answers will be the same. Let's take any one angle. Sine of 45. What is sine? Opposite side upon hypotenuse. So sine of 45 degrees will be opposite side upon hypotenuse. Even if you consider this angle C is 45, opposite side upon hypotenuse, again 1 upon root 2. So opposite side of 45 degrees is BC, hypotenuse is AC. Let's substitute. Opposite side upon hypotenuse BC is 1 upon hypotenuse is root 2. So sine of 45 is 1 upon root 2. Let's find out how we got cos, also 1 upon root 2. So cos of which acute angle? 45 degrees. What is cos of any angle? What is the general formula? Cos of 45 is adjacent side upon hypotenuse, AB upon AC. How much is AB? AB is 1. How much is AC? Root 2. So let's substitute 1 upon root 2. So over here again cos of 45 is 1 upon root 2. The third, tan of the same angle 45 degrees. Tan of 45 degrees. What is tan? Tan of any angle is opposite side upon adjacent side, that is BC upon AB. How much is BC? Let's see and substitute. BC is 1, AB is also 1. 1 upon 1 which is equal to 1. So tan of 45 is equal to 1. So children, we have recalled what we have studied in the earlier classes. For any particular angle, by putting in the measurements depending upon that type of angle, in that right angle triangle, we are able to particularly find out the trigonometrical functions of those acute angles. Now, if we have to write down the inverse ratios of 45 degrees, what answer do we get? Let's find out. Inverse of sine, we know, is cosecant. That is also called as cosec. Cosec of which angle? 45 degrees. What is cosec? It is inverse of sine. So inverse of sine, hypotenuse upon opposite side, that is AC upon BC. So root 2 upon 1. That is equal to root 2. So sine 45 is 1 upon root 2. Cosec 45 will be root 2. Inverse of cos of 45 is sec of 45 degrees. What is sec? It will be hypotenuse upon adjacent side. That is root 2 is the hypotenuse upon the adjacent side, that is 1. Just opposite, AC upon AB. So root 2 upon 1, that is root 2. Inverse of tan is cot of the same angle 45. What is inverse? Inverse of 45 degrees will be adjacent side upon opposite side, AB upon BC. Just the reverse, AB upon BC. How much is AB? 1. BC is 1, 1 upon 1, that is 1. So what did we see over here? For any particular angle, we found out their basic trigonometrical functions as well as their inverses. Now, to move on, if we take another triangle, not an isosceles right angle triangle, which we have just done it, let's take some other right angle triangle where angle C is equal to 30 degrees. So how much will angle A be? Angle B is 90, angle C is 30. So angle A will be equal to 60 degrees. Right. Now how do we calculate the ratios sine, cos and tan of 30 degrees or 60 degrees? Right. So to begin with, we know this type of triangle is which type of triangle? A 30, 60, 90 degrees triangle. So according to the theorem, we know the side opposite to 30 is always half the hypotenuse. Side opposite to 60 is always root 3 upon 2 times the hypotenuse. This theorem we have already done. Which is that theorem? 30 degrees, 60 degrees, 90 degrees theorem, which gives us the relation between the two sides opposite to 30 degrees and 60 degrees in relation with the hypotenuse. So once again, the side opposite to 30 is always half the hypotenuse and side opposite to 60 is always root 3 upon 2 times the hypotenuse. Now, to find out and figure out the values of the trigonometrical functions, we will have to assume some sides. So it is up to us, children. Either we assume the hypotenuse, because AB and BC, the relation is always compared with the hypotenuse in a 30, 60 and 90 degrees theorem. Let's assume hypotenuse as 2 units or 1 unit. So if I take this as 1 unit, how much will be the side opposite to 30 degrees? Side opposite to 30 is always half the hypotenuse. So that is AB is always half the hypotenuse. How much is the hypotenuse? Hypotenuse is equal to 1. So half into 1 will be 1 upon 2. So this measurement of AB is half unit. What about the side opposite to 60 degrees? That is BC. That is always root 3 upon 2 times the hypotenuse. So root 3 upon 2 times the hypotenuse. How much is the hypotenuse? 1 unit. Can we deduce anything? No. So let's multiply the numerators. Root 3 into 1 is root 3 upon 2. So we got AB, we got BC as root 3 upon 2. Now let's calculate, children, the values of sine, cos and tan. Sine. Let's find out sine of 30 degrees. What is sine? Sine is always opposite side upon hypotenuse. AB upon BC. AB upon BC. How much is AB? AB is half upon BC. How much is BC? Root 3 upon 2. Your sine of 30 will be opposite side upon hypotenuse, that is 1. Sorry children. AB upon AC. AB is equal to half. So let's substitute half upon 1. Now how do we calculate? Numerator fraction as it is, multiplied by the denominator. What is the denominator? 1. 1 means 1 upon 1. So when division changes to multiplication, reciprocal of this will also be 1 upon 1, which is equal to, you cannot reduce. So numerator into numerator upon denominator into denominator. So sine of 30 degrees is equal to half. So sine 30 is half. How did we calculate? We assumed that the hypotenuse is 1 unit. We applied 30 degrees, 60 degrees, 90 degrees triangle theorem to get the side opposite to 30 degrees and the side opposite to 60 degrees. By applying that side opposite to 30 is half the hypotenuse. So half into 1 gives me half units. Side opposite to 60 degrees is equal to root 3 upon 2 times the hypotenuse. Hypotenuse is 1. Let's substitute. Nothing gets reduced. So it is root 3 upon 2 times the hypotenuse. So by substituting, what is sine of any angle? Sine of 30 degrees over here again is opposite side, that is AB upon AC. How much is AB? Half. How much is the hypotenuse? 1. Numerator fraction as it is. Division change it to multiplication. Reciprocal of whatever is there in the denominator, that is 1. So multiply and we get the answer 1. So sine of 30 is equal to half. Let's move on to find out the cos value of 30 degrees. Cos of 30 degrees. Now what is the formula to find out cos of any angle? Cos of any angle is adjacent side upon hypotenuse. Adjacent side BC upon hypotenuse AC. Let's substitute. How much is BC? Root 3 upon 2. in the numerator upon AC is 1 unit. Let's move on with the mathematical calculations. Numerator fraction as it is, division change into multiplication and 1. So the answer is root 3 into 1 is root 3 upon 2. So cos of 30 is equal to root 3 upon 2. Now to move on to find out tan of the same angle. What is tan? We can use two methods, either tan of any angle. Tan of 30 will be sine of 30 upon cos of 30. That is one method. Or the formula. What is tan of any angle? Tan of any angle is equal to adjacent side upon opposite side. Is it right? Find out, children. Tan. Of which angle are we finding out? The same acute angle, 30 degrees. What do we get? Tan of any angle. The general formula is opposite. It is sine theta upon cos theta. So sine, what is it? Opposite side upon the adjacent side. Tan of 30 degrees. Opposite side is AB upon adjacent side is BC. AB upon BC. How much is AB? 1 upon 2 upon BC, root 3 upon 2. Let's solve it further. Tan of 30 is equal to numerator fraction as it is. Change it into multiplication. Division changes to multiplication. When division changes to multiplication, the reciprocal of the fraction in the denominator will be written. So root 3 upon 2 will be written as 2 upon root 3. What gets reduced? 2 ones are, 2 ones are. So you're left with 1 upon root 3. So tan of 30 is equal to, tan of 30 is equal to 1 upon root 3. So what did we see over here? We saw that particularly if you take any angle measurement for one of the acute angles, definitely by assuming the lengths and applying the other theorems which we have already learned, then we know that we can find out the values of any particular angle for sine, cos and tan, as well as sec, cosec and cot. Now, what about 60 degrees? Let's see. Let's find out one of the values. Sine of 60 degrees. The diagram can remain the same because in the same diagram we have got 60 degrees. So when one angle is 60, the other one will definitely be 30 degrees. We already have the measurements. What is sine of any angle? Sine of any angle is opposite side upon hypotenuse. For 60 degrees, which is the opposite side? Root 3 upon 2 upon the hypotenuse is 1. Let's move on with the calculations. Numerator fraction as it is. Division change it to multiplication. And inverse of 1 is 1 only. Or you can write 1 upon 1. Root 3 into 1 is root 3 upon 2. So sine 60 is equal to root 3 upon 2. Let's find out cos. Cos of 60. What is cos? Adjacent side upon hypotenuse. For 60 degrees, which is the adjacent side? 1 upon 2 upon the hypotenuse is 1. Let's move on. numerator fraction as it is, division change it to multiplication, inverse of the number in the denominator. So that is equal to 1 into 1 is 1 upon the denominator, that is 2. So cos of 60 is equal to half. How do we calculate tan of 60? Tan of 60 we know, children. The usual method is opposite side upon adjacent side, or let's use the other method, sine of 60 upon cos of 60. Let's see if we get the same answer. Sine of 60 upon cos of 60 degrees. So how much is sine of 60? Root 3 upon 2. This is the other way of calculating. What is cos of 60? 1 upon 2. Let's move on. The numerator fraction as it is. Division change it to multiplication. When division changes to multiplication, reciprocal or multiplicative inverse of the fraction which is in the denominator. So 1 upon 2 will be written as 2 upon 1. Does anything get reduced? Yes. 2 ones are 2 ones are. So what are we left with? We are left with root 3 into 1 is root 3. Denominator is 1. So tan of 60 with the other method is also root 3. So children, over here, as we have studied earlier, the different ratios can be calculated without learning them by heart, logically expressing it by using and taking support of the other theorems that we have studied, like 45, 90 degrees theorem, 30, 60, 90 degrees theorem, to calculate individually the values of any particular angle to find out the trigonometrical functions or their inverses. Now, to move on, if sine 30 is 1 upon 2, what will be cosec of 30? It will be 2 upon 1. Similarly, if tan 60 is root 3, what will be cot of 60? It will be 1 upon root 3. If cos of 45 is 1 upon root 2, then its inverse is sec. What is sec of 45? Root 2 upon 1. Why, children? Because we have studied earlier that the inverse of sine is cosec. So you have to just take the multiplicative inverses and that will be their values. The inverse ratio of cos is sec and the inverse ratio of tan is